Hi everyone, I am Renally Montano from BSENE. So basically, we will define first what is the word trigonometry. Trigonometry is the study of triangles and the relationship among their sides and angles. Trigonometry comes from the two Greek words. The first is trigon, which means triangle, while the other Greek word is metria, which simply means measures. So all in all, when we say trigonometry, it implies that we need to study about triangle measurement. Now, I will show you the 6 trigonometric ratios. But before that, let us identify first the different parts of our right triangle. First, we have the angle C. So as you can see here, our right angle is here. This means that the opposite side that our angle C is facing is the hypotenuse. Next is we have the opposite side and the adjacent side, but it only depends on which angle we will use. So, we have two acute angles, the angle A and angle B. So, let's say that our reference angle is the angle A. So, here, the opposite side that facing it, which is the side BC, is our opposite. Therefore, the bottom of our angle A would our adjacent, which is the opposite of our angle B. Next, we will define the 6 trigonometric ratios. So, one of the common acronyms that are used in trigonometry is the SOHCAHTOA and its reciprocal, which is the CHU-SHAKAW. So, S stands for sine, and the O and H is the opposite and the hypotenuse. And C stands for cosine, and the A and H is the adjacent and hypotenuse. T stands for tangent, and the O and A for opposite and adjacent. Then C for cosecant, and the H and O is the hypotenuse and opposite. S for secant, and the H and A is the hypotenuse and adjacent. And C for cotangent, and the A and O is the adjacent and opposite. We can now write the formula of our 6 trigonometric ratios. First is we have sine. So sine A is equal to opposite over hypotenuse. Next is the cosine. Cosine A is equal to adjacent over hypotenuse. Then next is the tangent. Tangent A is equal to opposite over adjacent. So next is the 3 left trigonometric ratios. So cosecant A is the reciprocal of our sine A. So we have cosecant A is equal to opposite hypotenuse over opposite. Then our secant, which is the reciprocal of our cosine, secant A is equal to hypotenuse over adjacent. Then the cotangent, which is the reciprocal of our tangent, cotangent A is equal to adjacent over opposite. So, this is now our 6 trigonometric ratios. So, let's have example number 1. Find the 6 trigonometric ratios of angle theta. So, here is our angle theta. So, as you can see, the given of our right triangle has one missing part. So, to get the hypotenuse of our right triangle, we can use the Pythagorean theorem. The c squared is equal to a squared plus b squared. So RC is the unknown. Then let's say that our a squared is the 8 squared plus our b squared is the 6 squared. Then let's simplify. We can have 64 plus 36. This is equal to 100. So to take the square root, so RC now is equal to positive 10. So the value of our hypotenuse is equal to 10. So if our sides in our right triangle are already complete, We can now get the 6 trigonometric ratios. So again, our formula is the SOHCAHTOA and its reciprocal, the CHU-SHAKAW. So our reference angle this time is the theta. The side 10 is our hypotenuse, then the 6 is our adjacent. Then 8 is our opposite, which is the opposite of angle theta. First, we have the sine theta is equal to opposite over hypotenuse. The opposite is 8 over the hypotenuse, which is 10. Then get the lowest term, we have 4 over 5. Next is cosine theta is equal to adjacent over hypotenuse. The adjacent is 6 over hypotenuse, which is 10. The lowest term we get 3 over 5. Next is the tangent theta is equal to opposite over adjacent. Our opposite is 8 over our adjacent, which is 6. The lowest term we get 4 over 3. We can now easily write its reciprocal. The reciprocal of sine theta is the cosecant theta is equal to hypotenuse over opposite. We have 5 over 4. Next is the reciprocal of cosine theta. The secant theta equals to hypotenuse over adjacent is equal to 5 over 3. Then we have the reciprocal of tangent theta. The cotangent theta is equal to adjacent over opposite is equal to 3 over 4. Now, we will talk about the law of sines, also known as the sine rule. This law of sines is particularly used in solving oblique triangles. So, let us discuss first what is the formula used for the law of sines. What we have here is A over sine A is equal to B over sine B is equal to C over sine C. We also have different version of it, wherein we will flip the given formula or the given fractions, wherein the sine A, sine B, and sine C are in the numerator, while the side A, B, and C are in the denominator. But it's all the same anyway, so don't worry. So, let's start with the first example. In triangle ABC, we have given angle B, which is 141 degree, angle C, which is 23 degree, and side A, which is 9 units. Then, find angle A, side B, and C. First, we will list down all the 6 parts of a given triangle. Let's start with angle A and angle B and angle C. In the given problem, it's already given that B is 141 degree and C is 23 degree, while angle A is missing. The next, we will list down the 3 sides. We have side A, side B, and side C. So, how can we determine where's the location of 3 different sides? Now, our reference is the given angles. Here, our side A is 9 units, which is the opposite of our angle A. Now, if our angle B is here, we can write the side B to its opposite. Then our side C is the opposite of our angle C. Now, we have missing side B and C. Let's begin in solving the angle. We can use this formula. We have A plus B plus C is equal to 180 degree. Then simplify, we have A plus 141 degree plus 23 degree is equal to 180 degree. We can get the sum of 141 and 23. We have A plus 164 degree is equal to 180 degree. Then, let's subtract 180 degree and 164 degree. We have A is equal to 16 degree. We have now left with side B and C. In solving for sides, we will check what letters are complete. So, since we have side A and angle A, we can use this formula. The A over sine A is equal to B over sine B. To look for side B, substitute the values. We have 9 over sine 16 degree is equal to B over sine 141 degree. Now, we can cross multiply. The B times 16 degree is equal to 9 times sine 141 degree. Our target is to get the B. So, we need to cancel this out by dividing both by sine 16 degree. So, we have here our B is equal to 9 sine 141 degree over sine 16 degree. To solve easily, just use your calculator, and with that, we can get the answer. B is approximately 20.5 units. Then, let's solve for C. Same process, just look for complete letters, then substitute the given values, then cross multiply, and to get the C, cancel out by dividing both sides. Then calculate. We can get the C is approximately 12.8 units. Around a time between 10 to 70 AD, a Greek mathematician by the name of Hero of Alexandria, also known as Heron of Alexandria, devised a unique formula to calculate the area of a given triangle. So, is there a formula that allows us to calculate the area of a triangle if we have values of all three sides? Well, the answer is yes. That brings us to the unique formula devised by Heron of Alexandria, which was named after him, and it is known as Heron's formula. So, what does this formula look like? Let us find out. Now, consider that you have a given triangle with side A, B, and C. Now, how do you calculate the semi-perimeter of this triangle? It is essentially 2 perimeter, which is the sum of all sides divided by 2, right? If you have the 3 sides of a triangle and its semi-perimeter, you can easily calculate the area using this formula. The area is equal to root of S times S minus side A times S minus side B times S minus side C. With this, you only need to know the measures of the 3 sides, which will give you the semi-perimeter of the triangle. And by substituting all these values in the given formula, we have the area of a triangle. Simple enough. So our first example is to find the area of a triangle with side 9 cm, 12 cm, and 15 cm. So we have to take the A is equal to 9 cm, B is equal to 12 cm, and C is equal to 15 cm. So we start off calculating the semi-perimeter, which is half of all sides, and that gives us the S is equal to 9 plus 12 plus 15 divided by 2, which is 36 divided by 2, and that comes to 18 cm. Area is equal to root S times S minus A times S minus B times S minus C. And we just put the value of the area. Then we get under the root sign 18 times 18 minus A times 18 minus 12 times 18 minus 15. On simplifying, we get area is equal to Under the root sign, 18 times 9 times 6 times 3. Then we get the square root of 2,916. Then we get the final area is equal to 54 squared centimeter.